Hi students, and welcome to another video lecture on logic design. To get started with this video, let us do a quick revision. Recollect that digital circuits are of two types, combinational logic circuits and sequential logic circuits. In this video, I will give you a brief introduction into sequential logic circuits. The block diagram for a combinational circuit looks like this. A combinational circuit will have some inputs and will have some outputs. The outputs are dependent on the inputs given to the circuit at the time. We have also seen that combinational circuits are very easy to design. A combinational circuit has no memory or feedback designed into the circuit. In contrast, this is what a sequential circuit looks like. The first thing to notice is that it is made up of a combinational circuit. It also has a memory element in it, such that the output of the circuit can be stored in that memory element and then can be introduced as input back into the circuit. Besides this, it will also have some inputs and outputs, such that the output is dependent on the inputs. But sometimes the output may be dependent on some previous input level conditions also. Because of this, sequential circuits are a little complicated to design. Sequential circuits are further classified as synchronous and asynchronous. Let's just first learn about synchronous sequential circuits. A synchronous sequential circuit is one which is controlled by a clock signal. A synchronous sequential circuit will be active only when the clock signal is present. Otherwise, the circuit will not function as it should. So what is this clock signal? A clock signal is a signal that oscillates between a high state and a low state. A sequential circuit will simply follow this signal in time to coordinate all its actions based on the clock signal. So this is what a clock signal will look like. It is represented by a square wave, and the time it takes for the clock to switch from 0 to 1 and back to 0 is a clock period. On the other hand, asynchronous circuits are not controlled by the presence of a clock. Events can take place at any time when the input is applied. Let me now introduce you to a concept called as latch or a flip-flop. There is a small difference between a latch and a flip-flop, which I will tell you about in the next slide. Let us first find out about what is a latch or a flip-flop. A latch is the most basic memory element of a sequential circuit. It is made up of an assembly of logic gates that are interconnected in such a way that it is capable of storing just one bit of data. Now the thing to note here is that a logic gate by itself has no storage capacity. But when several logic gates are connected together in a certain way, they permit information to be stored. Flip-flops or latches are considered to be the basic building block of most sequential circuits. It has two states, and it can remain in either one of these states for an indefinite amount of time. If you want the state of a flip-flop or a latch to change, then you must trigger it or force it to change state by using a proper triggering signal. It is also called as a binary memory device or one-bit memory or a bistable device. This is a simple block diagram to explain what a latch looks like. It will have some inputs and it has two outputs Q and Q bar. The state of the latch refers to the state of the normal output Q. If Q is equal to 1, then the state of the latch is said to be high. If Q is equal to 0, then the state of the latch is low. Q bar or Q dash is nothing but the inverted value of Q. Now this latch can become a flip-flop if there is a clock signal present. So in other words, a flip-flop is nothing but a latch with a clock signal. So there you have it. That is the difference between a flip-flop and a latch. That's all for now. Connect to the classroom for more videos and study material.